I will proceed to implicit differentiation. So for example, we have an implicit function. So this is a function in the form of wherein that function is expressed in several variables. If we are to differentiate our implicit functions, we may not solve for the value of y, or at the end or after differentiation, we will be having both variables, x and y. So first example, implicit differentiation, we are to differentiate the function x cubed plus y cubed is equal to 27. So we are allowed to differentiate both variables. So we have applying power or chain rule. Okay, for x cubed, bring down the exponent 3x cubed, then the exponent minus 1. Derivative of x is we have dx plus we have that is bring down the exponent 3y. This is 3y cubed minus 1. Derivative of y or the base is dy, and derivative of constant is 0. So you may divide both sides of the equation by, let's say, 3, and also with the dx, just to eliminate the 3 constant or the coefficient 3. Dividing both sides or all terms by 3 dx. This is now the same as we have x squared. X squared plus y squared. We have now dy over dx equal to 0. So we have the equivalent of y squared dy over dx now equal to negative x squared. So dividing both sides again by y squared. So divided by y squared, we'll be having the equivalent. And the equivalent of dy over dx, or the same as a y prime, is equal to, we have negative x squared divided by y squared. So in the end, we'll be having two variables. So that is implicit function. It is not, maybe not possible to solve for the value of y. So these are for first example. For our next example, under implicit differentiation, so we have equation 6xy plus y squared is equal to 5. Okay, for this case, we may isolate first the constant. Okay, para hindi lang siya makigulo. Let's say we are to apply the product rule here. So your first term, okay, again, if you are to recall the product rule, the derivative of the product of u and b is your first term, derivative of the second term, plus the second term, derivative of the first term. So we'll be having that is, factoring out 6 first, your first term is x, your second term is, derivative of the second term is dy, plus your second term is y, derivative of the first term is dx. Then we have plus y squared, this is plus 2y raised to 2 minus 1, okay, the chain rule, minus 2 minus 1 dy, derivative of constant 5 is, we have 0. So this is the same now as 6x dy plus 6y dx plus, we have, this is 2y dy is not equal to 0. So we may have the terms, we have the terms with dy. Then we may transpose this one. So this is, we have 6x plus, we have 2y, I will factor out dy, is not equal to transpose this one, this is negative 6. Okay, we have negative 6y dx. So dividing all terms, okay, I'll be dividing all terms with dx. Or dividing both sides of the equation with dx. So we'll be having dy over dx is now equal to, or that is 6x so this is 6x plus 2y, this is multiplied by dy over dx is now equal to negative 6y. Okay, so again, we have to divide both sides of the equation with 6x plus 2y. This is 6x plus 2y. So we have an equivalent of dy over dx, or the same as the y prime is equal to, this is negative 6y all over 6x plus 2y. So I guess we can still simplify this one. When we factor out, this is negative 6y, we factor out 2 from the numerator, denominator, this is 2 times 6, this is 2 times 3x plus y. So we have negative 6 over 2, you'll be having the equivalent of y prime is equal to negative 6 over 2 is negative 3y divided by 3x plus y. So this will be the equivalent of y prime. And that is for our second example. And so we proceed to the determination of a tangent line of a given curve or of a given function. So for example, we have a function or of a curve. And let's say this is in terms of y, if a line will intersect this curve at exactly one point, that is the same as the tangent line. So tangent line will intersect a given curve at exactly one point. Okay, so that is the tangent line, and if we are to draw a perpendicular line to that tangent, so perpendicular, it will intersect the tangent line at 90 degrees. So this is called the normal line. Okay, so how to determine, for example, how to determine the equation of a tangent line, how to determine the equation of a normal line on a given point. So let's say this is a specific point xy on the curve. Okay, on the curve y. So basically, if we say y prime, that is the first derivative of the given function y, that is the same as the slope. Okay, the slope of the given function on the given point. So we have in your analytic geometry, I think you're using the slope m. Okay, how to compute for the slope of a given line? So the slope is basically equal to the change in y divided by the change in x, or basically this rise over run. Okay, the change in rise over run. So if we are able, for example, if we are able to determine, let's say m sub t, this is the slope of the tangent. If m sub t is the slope of tangent line, how to determine the slope of the normal line? So we have the slope of the normal line, let's say m sub n is basically equal to the negative reciprocal of the slope of the tangent line. Okay? So that is the slope of the normal line. Or how to determine, for example, the slope of a given line from your analytic geometry. Let's say this is y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Okay, so let's try an example. And let's have our example. So determine the equation of the tangent line and normal line to the curve y is equal to x squared at the given point, that is 2, 4. Okay, so sabi natin kanina, so what is the definition of y prime? What is the definition of the first derivative of the given function? That is the same as the slope equation. So take note, we have y prime will give us the slope equation, or basically the slope. So we have the function, that is, we have y is equal to x squared. We need to determine the first derivative. The first derivative is, that is equal to, the first derivative is equal to dy is equal to 2x dx. So dividing both sides of the equation with dx, so we have dy over dx, that is the same as the change in rise over the change in run, or that is the same as the slope is now equal to 2x. Okay, we have now the slope equation. The slope equation is y prime is now equal to 2x. So how to determine the slope? We have the slope. Okay, this is the slope at the given point or the given coordinate, that is 2, 4. We have the slope equation, y prime is equal to 2x. All we have to do is substitute the value of x. So basically this is x and y. We have y prime is now equal to twice times, twice of 2. So we have y prime is equal to 4. So how do we express, for example, how do we determine the equation? I'll be using the slope equation. I'll be using the form of slope. A definition of slope is m is equal to, let's say, y minus y1, this is divided by x minus x of 1. So again, let's say from the given point, that is x of 1 is equal to 2 and y of 1 will be the 4. Okay, so what is the slope? Okay, what is the slope of the curve at the given point 2, 4? That is 4. So we have this is 4 equal to, so take note that y prime is the same as the slope of the tangent line. Okay, so first thing to solve, we are solving for the equation of the tangent line. Okay, later or mamaya, yung normal line. Okay, so we have, this is 4 is equal to y minus, what is y1? That is 4. This is divided by x minus, what is the abscissa of the given point? That is, this is 2. So by cross multiplication, that is 4 times x minus 2. This is the same as 4x minus 8 is now equal to y minus 4. So I'll be having the equation, this is the same as 4x minus y minus 8 plus 4 is equal to 0. So we have 4x minus y, this is minus 4 is equal to 0. So this is the equation, okay? This is the equation of the tangent line. And the equation of the tangent line, tangent to the given curve, y is equal to x squared at the coordinate 2, 4. So how to determine the equation of the normal line? So we have the equation of the normal line. We need first to determine the slope of the normal line. So let's say we have, this is m sub n. M sub n is or the slope of the normal line is equal to the negative reciprocal of the slope of the tangent line. So that is negative 1 over m sub t. So we have from y prime, the slope of the tangent line is 4. So ang slope ng normal line will be equal to negative 1 over 4. So we can still use this one from your analytic geometry. So we have, this is now m sub n, and we have m sub n is equal to y minus x of 1 divided by y minus, y minus y sub 1 divided by x minus x of 1. So we'll be having the slope of the normal line is equal to negative 4 is equal to, we have y minus, so this is our y1, that is 4. This is divided by the slope, divided by x minus x of 1 is y2. So we'll be having, we may do cross multiplication. So let's say I'll be putting the negative sign dito sa 1. We have negative 1 multiplied by x. That's the same as negative x. Ay plus 2 is equal to, we have 4y minus 16. So this is the same as if I just transpose, we'll be having 4y plus x, then negative 16 minus 2 is now equal to 0. Just to rearrange, x plus 4y minus 18 is now equal to 0. So this will be the equation, okay, the equation of the normal line. So equation of the normal line, normal to the curve y is equal to x squared at the given point 2 4. So this is our example.